Day 234 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. This time we're at day 234, y'all, still going strong. Today we have question number 129, sum root to leaf numbers. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand. So let's get into the question, y'all. The question says, you are given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. For example, the root to leaf path 1, 2, 3 represents the number 123. Return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit in a 32-bit integer. A leaf node is a node with no children. So, let's break that down by looking at the example. So let's look at example 1. In example 1, we have the input root equals a binary tree, 1, 2, and 3. The output is 25. Let's see how they got this output from this input, right? We started with 1, 2, 3, and now we're at 25. It's not that difficult. All they did was the first root to leaf path is 1 to 2 represents the number 12, right? So 1, 2 right here, that represents 12 because it's 1, 2. Then it says the root to leaf path 1, 3 represents the number 13. So it goes 1, 3, right? So that's going to represent 13 for us. So we put a 13 right here. Then, therefore, the sum 12 plus 13 equals 25. When we add 12 plus 13, we get 25, thus the output being 25. So let's look at example 2 where the numbers might be a little bit larger, but it's the same principle, y'all. Not that difficult at all. So in example 2, we have the input root equals a binary tree 4, 9, 0, 5, and 1. The output is 1026. This time, the root to leaf path 495 represents the number 495. So that's 495, just like that. So we could put the 495 over here. Boom. Then the root to leaf path 491 represents the number 491. See, it goes 491, going from the root to the leaf. Y'all remember, a leaf is a node with no children, right? So we're just going from top to bottom, root to leaf. So now we got 491. We could put that over here. So we say 491. Then we come over here and we have just 40. So the root to leaf path 4 to 0 represents the number 40. So we just come over here and that's put 40. Now we need to add them all together, right? So we have come over here. We have 5 plus 1. That's going to give us 6. Boom. Then we come right here. 9 plus 9 is 18, plus 4 is 22, so we could put the 2 right here. We're going to carry the 2 over here. 2 plus 4 is 6, 6 plus 4 is 10, so that's how we got 1026, right? Thus the output, therefore the sum of 495 plus 491 plus 40 equals 1026, and that's how we got the output. So, now that we understand the question, y'all, let's get into the fun part, the actual solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. And then after you do that, don't forget to like, comment, and subscribe, y'all. Just bring a mouse right over here. Now, let's get into the solution, y'all. The solution not that difficult at all. And the first thing we need to do is we need to create an array that's going to store all the numbers formed by the root to leaf path, right? So once we see all these numbers, we need to create an array to append these numbers to, right? These numbers that we come across in our root to leaf path. So in order to do that, we're just going to declare a variable, call it an array, and we'll set that equal to an array of integers like so, and we will initialize that with parentheses like that. Now we need to check if the root is nil, right? Because if the root is nil, that means the tree is empty, and if the tree is empty, we could just return 0. So in order to do that, we're going to say guard, create a guard statement, say guard let root equal root, excuse me, y'all, else we could just return 0, just like that. Now we're going to come down here and we need to create a helper function that's going to help us to perform a depth first search traversal on the tree, right? So in order to do that, we are just going to say func. We're going to keep this function inside this original function. We're going to say func DFS for depth first search, open up the parentheses, underscore, say root, colon, that's going to be a tree node. Then we're going to say comma, underscore, cur, colon, and that's going to be an integer, and cur is going to be the current number formed by the path from the root to the current node, right? So that's going to help us keep track of the sum as we're going down, or keep track of the current node as we're going down from the root to the leaf. Now we come out here, open up the brackets. First thing we need to do is we need to update the current number by appending the current node's value. So first thing we need to do is we're going to need to declare a variable. We're going to call that new cur. We're going to set that equal to cur, 1r times 10, boom, plus the root dot val, just like so. Now, if the current node is a leaf node, we need to check for that, right? We need to make sure that we need to know when we reach a leaf node, right? And then when we reach the leaf node, we need to add the number formed by the path to the array. So in order to do that, we're going to say if root dot left is equal sign nil, and two and signs, root dot right is equal sign nil. That means we reached a leaf node. Now we need to append that number that we just found or just formed by the root, the leaf. We need to append that to the array that we have created up here. So in order to do that, we're just going to say array dot append, open up the parentheses, new cur, just like so. Now come outside that if statement, because we're not done yet. Now we need to, just in case we're not at a leaf node, we still need to go through the case where we recursively traverse the left subtree if it exists, right? So if the left subtree exists, we need to recursively traverse that. So in order to do that, we're going to say if let left equals root dot left, open up the brackets. Now we're going to use some recursion. We're going to say DFS, open up the parentheses, left comma new cur, just like that. Now we need to do the same thing for the right side. So we're going to say if let right equals root dot right, open up the brackets, and we're going to do the same thing, DFS, open up the parentheses, right comma new cur, just like so. But we're not done yet. We're getting there though. Now we need to initialize a variable that will store the sum of all of the numbers. So we're going to do that by declaring a variable. We're going to say var res, and we're just going to set that equal to 0 to start, right? Now we need to iterate through the numbers in the array that we created, and then we need to calculate the sum. So in order to do that, we're going to say for I in array that we created up here, right here. Oh yeah, don't forget, y'all, we actually need to call this helper function as well. So hold on, to do that, we could just say come outside, come underneath the guard statement. We could say DFS, open up the parentheses, root comma 0, boom. Excuse me, y'all, just like that, y'all, because we just created this function. We still need to call it, so we can call it right here. Now we're back down here. While we're iterating through the array that we created, we need to add all of the numbers together. So we're just going to say res plus equals I, boom, just like that. Then we could come down here, and now we need to return res, which is the total sum of all the root to leaf numbers. So we could just say return res, just like that. Now let's run it, see how it runs. Hopefully it runs properly. Okay, oh, we need a bracket right here. Sorry, y'all, put a bracket right there. Let's see, that should be, oh, we need to put a bracket right there, but we also are gonna need to put a bracket down here as well. So now let's run and see how it runs. Let's see. Boom. So let's submit it. Make sure it stays accepted, y'all. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I like to see. Now, before we leave, y'all, get one more look at the code, y'all. Get one more look at the code. Read it, learn it, love it. Get one more look. It's not that much. Hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.